Okay, let's now talk about the popular LCM and HCF. Right, so LCM and HCF. So these are acronyms. Okay, these are acronyms. So LCM stands for the least common multiple. The least common multiple. Alright, so before we talk about LCM, let's try to understand the meaning of a multiple. So what is a multiple of a number? Right, so simply the multiple of a number is the product of multiplying that number by a natural number. So the multiple of any number is the product. Product has to do with what? Multiplication. So the product or the result of multiplying that number by a natural number. And you know natural numbers start from 1. Right? So if I ask you to list the multiples of 3, all I'm asking you to do is that multiply 3 by the natural numbers and give me the result. So starting from 1, 3 times 1 will give me 3. Right? 3 times 2 will give me 6. 3 times 3 will give me 9. 3 times 4 will give me 12. 3 times 5 will give me 15. 3 times 6 gives me 18. 3 times 7 gives me 21. 3 times 8 gives me 24. So that is what we mean by the multiple of a number. The result of multiplying that number by natural numbers. That is from 1, 2, 3, 4, and it goes on and on and on. So here too, it tells us that the set of multiples of any number is an infinite set. Right, so as you can see, you are seeing the ellipsis here, meaning that this set is an infinite set. Alright, okay, let's now look at the multiples of 4. So multiples of 4 will be gotten by multiplying the number 4 by natural numbers starting from 1. Right, so 4 times 1 gives us 4. 4 times 2 gives us 8. 4 times 3 gives us 12. 4 times 4 gives us 16. 4 times 5 gives us 20. Then 4 times 6 gives us 24. And the list goes on and on and on and on. Alright, so that is what we mean by the multiple of a number. So when we talk of the least common multiple, all we are saying is that we are comparing the set of the multiples of two or more numbers, and then we are identifying the least amongst the two sets. So first of all, we have to identify the common multiples. The common multiples, that is the intersection of these two sets. Right, but then afterwards we look at the least or the smallest amongst the common multiples. So here we can have some common multiples here, right? So as you can see, 12 is here, 12 is here. So 12 is a common multiple of 3 and 4. Now 24 is here, 24 is also here. So 24 is a common multiple. But LCM says least common multiple. So what is the least between 12 and 24? It is what? It is 12. So the LCM is simply 12. Right, so the least common multiple is simply the smallest of the common multiples of any two numbers or two or more numbers. Right, so that is a general concept of the least common multiple. Okay, let's come to the highest common factor. That is the HCF, highest common factor. It is sometimes referred to as the greatest common factor. So sometimes you see GCF. At GCF, it is the same, right? So before we look at the entire concept of highest common factor, let's look at the keyword here, which is the factor. Okay, the factor. So what is a factor? Now the factor of a number is simply a natural number that can easily divide that number, right? So if I ask you to give me the factors of prime numbers, just as we saw, prime numbers have only 2 factors. So if I ask you to give me the factors of, let's say, 5, all you tell me is 1 and 5, because the only number or the only numbers that can divide the number 5 is 1 and the 5 itself. right? So a factor is simply the number or a natural number that can easily divide a given number without any remainder. Alright, so let's look at some examples here. So factors of 16. So if I ask you to list the factors of 16, you are going to confidently say that the factors of 16 is or are 1, 2, 4, 8, and 16. Now let me give you this simple clue. For any given number, 1 and the number itself constitute the primary factors of that particular number. That is why prime numbers have only 2 factors, and even with those 2 factors, it is 1 and the number itself. Right? So for any given number, 1 becomes the least factor, and then the number itself becomes the highest factor. Right? But then we'll have some other numbers that can divide the number. That is if the number is a composite number, right? So you see, I am applying, or we are applying at all that we've learned so far. So we've looked at prime numbers, we've looked at composite numbers, and we are applying our knowledge on all these types here as well, right? So factors of 16, clearly 16 is a composite number, meaning it has more than 2 factors, right? So 1 becomes the least factor, and then the number itself, 16, becomes the highest factor, or the greatest factor, right? But then we can have other factors like 2, because 2 can divide 16 8 times, 4 divides 16 4 times, 8 divides 16 2 times, right? So this is the set of the factors of 16, and for sure the factors of any number is a finite set, right? The set of factors of any given number is a finite set, so it means it has a beginning and it has an end, unlike the multiples of a number, which is an infinite set, right? So it means we don't know the limit of the multiple of any number, right? But for factors, we know of the beginning, we know of the end, right? So that is that for factors. Okay, let's look at the factors of 12, right? The factors of 12. Please pardon me here for the typing error, right? So it's supposed to be factors of 12. So for factors of 12, we are going to have 1, 2, 3, 4, 6, and 12. Right? 1, 2, 3, 4, 6, and then 12. Right? So clearly 1 is always the smallest factor, and then 12 is the greatest factor of the factor of any number. Alright, so we have 2 sets of factors of 2 numbers. Now the highest common factor, as the name suggests, looks at common factors, right? So first of all, we are going to focus on the common factors, then we are going to look at the highest amongst the 2 sets, right? So let's first look at some common factors. So we can make mention of 1. 1 is here and 1 is here. 2 is here, 2 is here, right? Yeah, I think. Okay, 4 is here and 4 is here, right? So we have 3 common factors. But what is the highest among these 3? It is obviously 4, right? So the HCF of 16 and 12 is simply 4. I believe it's well understood, right? Okay, let's move on. Okay, let's look at an interesting concept in mathematics, that is the factor tree. The factor tree. And whenever we talk of the factor tree, what comes in mind is the product of prime factors. The product of prime factors, right? So let's look at the structure of the factor tree, right? So this is how the factor tree looks like. So we have the left leg here and then the right leg over here. Alright, so let's look at how to find the product of prime factors using the factor tree. How to determine the product of prime factors of a number using the factor tree. right? So to help us, we are going to pick an example here, right? So as I run you through the steps, I'm going to refer you to this example so that you can easily catch it. Okay, so the first point is always start with the smallest prime number that can divide the given number and write it on the left leg, right? So our number here is 36, so we have to determine the product of prime factors of the number 36, right? So what we do is that we open the factor tree, right? Open the factor tree, and then we write the smallest prime number that can divide the number 36 on the left leg, right? And let me give you this simple clue. Now, so long as the number here is an even number, the smallest prime number that can divide the number up here must be what? Must be 2, because 2 is the smallest even prime number, right? So that is it. And then we always keep the prime factors on the left leg. Don't forget this. We always keep the prime factors on the left leg, right? So that is step 1. So we have 2 here, right? Now step 2, write the other factor on the right leg. So if 2 can divide 36, how many times can 2 divide 36, right? We are going to write that other factor on the right leg here, right? So for sure 2 divides 36 18 times, so we write the 18 on the right leg over here, right? Good. Let's move on. The third step. So we are going to keep dividing the numbers on the right leg till we get a prime number on the right leg, right? So we have 18 on the right leg over here. Now, so long as this 18 is not a prime number, we are not going to stop. We are going to open another factor tree. Then we are going to go through the same procedure. So we are going to write the smallest prime number that can divide the number 18, and that is also 2. Then we keep the other factor on the right leg. So how many times will 2 go into 18? It is 9. So we keep the 9 on the right leg over here, right? So we are going to keep dividing till we get a prime number on the right leg, right? So 9 is not a prime number, so we are going to open another factor tree, right? So what is the least prime number that can divide the number 9? It is 3, right? So how many times will 3 divide 9? It is 3. Now when you get a prime number on the right leg, you stop. So because 3 here is a prime number and it is on the right leg, it means we have come to the end of the whole show, right? Then afterwards we pick all the prime numbers on the left leg as well as the last prime number on the right leg and write them as the product of prime factors, right? So since we are going to end here, we are going to pick all the prime factors here, right? So all the prime numbers on the left leg plus the last prime number on the right leg here, and then you are going to multiply them, right? You are going to write them as a product of prime factors, right? So you are going to have 2 times 2 times 3 times 3. So as you can see over here, 2 times 2 times 2 times 3 times 3, right? And then we are going to express the product as an exponent. So we are going to write the numbers in an exponential form, right? So clearly 2 times 2 is 2 to the power 2, right? According to the law of indices, when 2 numbers are multiplying, they have the same base, you just add up their exponent, and any number starting on its own has an exponent of 1. So you're going to have 2 to the power 1 plus 1, and that gives us 2 to the power 2. The same applies to 3 times 3. You're going to get 3 to the power 2, right? So you're going to get 3 to the power 1 plus 1, and that gives us 3 to the power 2, right? So it means that the product of prime factors for the number 36 is 2 to the power 2 times 3 to the power 2, right? So that is how we find the product of prime factors of any number. All right, okay, let's proceed. Okay, let's now look at how to find the LCM of a number using the LCM of 2 or more numbers using the product of prime factors, Alright, so the first thing we do here is we find the product of prime factors of the given numbers. Right, so to help us understand, let's take a look at this example. So we have to find the LCM of the numbers 12, 18 and then 40. 12, 18 and 40. Right, so what do? We first find the product of prime factors of the given numbers. Alright, so for 12 we are going to find the product of prime factors, and we are going to apply the same method as we just saw. Alright, so we open the factor tree. We start with the smallest prime number that can divide 12, and that is 2, and 2 goes into 12 6 times, so we put a 6 over here. We open another factor tree beneath the 6. We start with the smallest prime number, that is 2, so 2 divides 6 3 times, and because 3 is a prime number we stop, and then we multiply the 3 numbers here, so 2 times 2 times 3. Then we express it in an exponential form, so we get 2 to the power 2 times 3. Similarly 18, right, so we open up the factor tree. We start with the smallest prime number that can divide the number 18, and that is 2. So 2 into 18 is how many times? It is 9 times, so we keep the 9 on the right leg. Since 9 is not a prime number, we open another factor tree. So how many times? So what is the smallest prime number that can divide 9? It is 3. So 3 into 9 is 3 times, so we keep the 3 on the right leg here. And since 3 is a prime number and it's appearing on the right leg, we stop. So we just write the 3 numbers here as the product of prime factors. So we have 2 times 3 times 3, right? And in an exponential form, we are going to get 2 times 3 squared. 2 times 3 squared. Finally 40. So 2 into 40 is 20, right? 2 into 20 is 10. 2 into 10 is 5. Then since 5 is a prime number, we stop. Then we write them as a product of prime factors. So 2 times 2 times 2 gives us 2 to the power 3, and then times 5. Alright, so that is the first step. So if you are asked to find the LCM of a given set of numbers, the first thing to do is find the product of prime factors of the given numbers. So that is what we've done here. Okay, let's move on to the next step. Select the common prime numbers with the highest exponent. Alright, so here the prime factors for 12 is 2 squared times 3, 18 is 2 times 3 squared, 40 is 2 to the power 3 times 5. So we have to select the common prime factors with the highest exponent. So for sure 2 is common here, 2 is also common here, 2 is common here. Right, so 2 is common to all the 3, right? But then which of the 2's carries the highest exponent? It is definitely 2 to the power 3, right? So we are going to select 2 to the power 3, right? So that is for the second step. Select the common prime numbers with the highest exponent. Also 3 is here, 3 is here, so 3 is common. Alright, so with LCM, even if the number is common to only 2 of them, right, it must not necessarily be for all the given numbers. So long as it is common to any 2 of them, we compare the 2 and then we pick the highest, the one with the highest exponent. So here it is 3 to the power 1, here it is 3 to the power 2, but then we pick the one with the highest exponent. So we're going to add 3 to the power 2, right, to it. Okay, then we select any other uncommon number. Emphasis on the word uncommon number. So here we've seen the common numbers, that is 2 and 3. Now if there's any other uncommon number, we just add it to it, right? So for sure there is an uncommon number here, which is 5. So 5 is only exclusive to the number 40, right, to the product of prime factors of 40. But then it is not common to 18 and 12. But with LCM, we are going to add any other uncommon number, right? So afterwards, you are going to multiply the selected numbers to get your LCM. right? So we are going to have 2 to the power 3 times 3 to the power 2 times the 5, and when you have to punch it on your calculator, the result is 360. But you can decide to leave your answer as product of prime factors, right? So that is how we determine the LCM, using the product of prime factors. The LCM of 2 or more numbers using the product of prime factors. I believe it has been well explained and well understood as well. Okay, let's move on. Okay, let's now look at finding the HCF using the product of prime factors. So assuming you are given 2 or more numbers and you're asked to find the HCF, the highest common factor, using the product of prime factors, how do you go about it? Right? So to help us go through the process, let's take an example here. We have to find the HCF of the numbers 8, 16 and 36. Right? So here, to the first thing we are going to do is we are going to find the product of prime factors of the given numbers, right? So for 8, we are going to find the product of prime factors, right? And that will give us 2 to the power 3. Right? I believe you are now acquainted with how to find the product of prime factors of any given number, right? So for 16, we are going to get 2 to the power 4. For 36, we are going to get 2 to the power 2 times 3 squared. Okay, let's now move on to the second step. Now we have to select only the common prime numbers that are common to all the given numbers, but with the lowest exponent. So for HCF, we are going to compare the various products of prime factors, and our aim is to select only the common prime factors that are common to all the given numbers. So there shouldn't be a situation whereby the prime number will only be common to 8 and 16 and not common to 36. No, the number must be common to all the given numbers, right? So here 2 is here, 2 is here, 2 is here, but then we are interested in the one with the lowest exponent, and that is what? 2 to the power 2. Right, so we just write it there, 2 to the power 2. So it means that we don't include any uncommon number. You see, with the LCM, we said we have to add any other uncommon prime number. For HCF, we don't include the uncommon numbers. We are only interested in what? In the common numbers, the common prime numbers with the lowest exponent, and the number must be common to all the given numbers. Alright, so 2 is here, 2 is here, 2 is here. Right, now 3 is here, 3 is not here, 3 is not here, so we don't consider 3. That is for HCF. So only the common prime number that is common to all the given numbers, but with the lowest exponent. So here we have 2 to the power 3, 2 to the power 4, 2 to the power 2. But what is the lowest amongst it? Or which of them has the lowest exponent? It is 2 to the power 2, right? And 2 to the power 2 is 4. So the HCF of 8, 16 and 36 is 4, right? So afterwards you multiply the selected numbers to get your HCF. Since the only candidate we had was 2 to the power 2, that is all that we are going to write, right? So 2 to the power 2, and the result is 4. Alright, I believe it has been well explained. I believe it is very simplified, right? Alright, so this is where we bring the lesson to a successful end.